we should be suffering from a dramatic climate anomaly on the day that we have Bill McKibben with us. David Orr is suffering from laryngitis, so I've been asked to pinch hit on the introduction of one of the most important environmental thinkers of our time and a personal hero of many of us, including myself, Bill McKibben. A real pleasure and an honor to introduce him. I think it's probably safe to assume that many in this audience already know quite a bit about Mr. McKibben, so I want to keep my remarks as short as possible. I think, as most of you know, Bill McKibben is a very well-respected and prolific environmental author. His first book, The End of Nature, published in 1989, now translated into over 20 different languages, was the first national bestseller that focused on the challenge of climate change. His most recent book, Earth, that's spelled E-A-A-R-T-H, explores what it means to live on a fundamentally different planet that we're now in the process of creating, and how we might build new kinds of communities that are resilient in the face of this challenge. 11 intervening books between The End of Nature and Earth, and numerous articles have deeply probed what it means to be human on a rapidly changing biosphere. His work as an author certainly justifies Time magazine's designation of Bill McKibben as the world's best green journalist. But I think many, particularly students in the audience, know Bill McKibben for his work as a creative activist and supporter of student activism on a global scale. In 2009, Bill McKibben led the formation of 350.org, a completely new kind of international environmental organization that harnesses the power of and creative self-organization potential made possible by the World Wide Web. The first mass event organized by 350.org resulted in over 5,000 individual demonstrations in over 180 countries throughout the world in what Foreign Policy magazine called the largest ever global coordinated rally of any kind. Bill McKibben has won numerous awards for his writing and for his work as an activist. He is Schumann Distinguished Scholar at our sister institution, Middlebury College. Bill McKibben strikes the balance between alarm, hope, and a practical call to action that we all stand to learn from and be inspired by. This evening, he will speak on global and local, on the front lines of the climate fight. Please join me in welcoming Bill McKibben.
What a pleasure to get to join you here, and I'm quite pleased by the weather. When your role in life is basically to be a professional bummer-outer of people, it helps when the weather cooperates. It's much harder on a beautiful spring day. It is an enormous pleasure to be at Oberlin. I have heard about this particular building so many times from so many places, and to get to see it in the flesh, as it were, and all of you in it, is a tremendous joy. And to get to arrive at the airport today and have my old friend David Orr there to pick me up, an even greater joy. The good book says that sometimes the prophet is without honor in his own country. I don't think that's probably true here. I think you guys all understand the role that David plays and has played for many years around the country as one of the absolute leading voices on this most important of issues. And now we hear over and over and over again from many, many directions about this nascent Oberlin project, and we have high, high hopes for it as a kind of way to show many other places what we need to do. So thank you all, David in particular, but you all for making that happen. It is, I'm afraid, far more my pleasure to be here than it will be for all of you. I'll try to end on a hopeful note, I promise. But I will, I'm afraid, just be plain depressing for a little while. Because I know that you all know everything there is to know about climate change and understand it all. And nonetheless, it's useful every once in a while just to review exactly where we are, because it's the particular set of conditions that we find ourselves in that set what kind of responses make sense. I did write the first book about climate change back in 1989, i.e. before you were born, and so I've had as much chance as anyone to follow the development of this story. We knew back then most of what you needed to know. You burn coal and gas and oil, put carbon dioxide into the atmosphere, the molecular structure of CO2 traps heat that would otherwise radiate back out to space. All that we didn't know was how fast this was going to hurt. And as I said, some of you were at Power Shift, yes, a few weeks ago. Thank you guys very much for being there. We'll talk a little more about that, because that was a really blessed couple of days. But as I said at the time, the story of the last 20 years basically has been, this is pinching a lot harder and a lot faster than we thought it was going to. That's what the burden of this last book with the strange title, Earth, which you kind of have to, you sort of really have to channel your inner Schwarzenegger to pronounce it, Earth. That was the burden of the book, and the first chapter of it is, well, the first chapter of it's incredibly grim. And I won't bother adducing all the proofs that I could. Trust me, I could go on for a long time. Let's just talk about what happened in the year since that book came out. It's been about exactly a year. And that year, 2010, turned out to be the warmest year for which we have records. 19 nations set new all-time temperature records. I think I might have told the story at Power Shift of being on the phone one day with our 350.org crew in Pakistan in sometime in early June, I think. And one of them said, very hot here today. And I was like, why would you, I mean, of course it's hot. It's Pakistan, it's July. I says, no, it's really hot here today. We just set the new all-time, all-Asia temperature record, 129 degrees. Okay. That's hot. That beats any story I can tell, you know. That's pretty good. There was a lot of heat like that in all kinds of places, and it took its toll in dramatic ways. The Arctic melted at a rapid, rapid pace for the fourth year. At some point last summer, both the Northwest and Northeast passages were open, and there was a yacht race through territory that even 10 years ago people thought no human would ever navigate, that it would always be frozen. In Russia, you saw the pictures on the news of that unbelievable heat wave. Moscow had never reached 100 degrees in the 250 years for which there were records. Hadn't even really gotten that close. It was above 100 degrees for 8 straight days at the beginning of August. That caused wicked fires and peat bogs across central Russia and wild smoke. But the biggest effect was that it really scared the Kremlin. That the accompanying drought was going to, well, was decimating grain yields. And so they stopped all grain export to the rest of the world. Turned around ships, turned around trains. It appears they're going to keep that policy in place this year. That's big news. Russia is the 3rd biggest grain exporter on the planet, and so the price of corn and wheat went up about 70% within a matter of weeks, and it's stayed high ever since. Which, you know, in this country, that's led to some food price inflation, you know, but we can deal with it. Since most of the food we eat has been so heavily processed, the price of the underlying corn or wheat, I mean, when you buy a, you know, in a box of, I don't know, Captain Crunch or something, that, you know, you basically pay about 4 times as much for the box as for the wheat. So it doesn't make that much difference. But it means that there are 1 billion or 2 people around the world tonight who are eating less than they would like to be having for dinner because they can't afford it. If what you eat is corn and wheat directly and the price goes up 70%, you're out of luck. You're out of luck too if you've, and this is probably apropos to be talking about right at the moment, you're out of luck if you live in one of those 6 or 8 places that in the last year has seen really wild mega floods on a scale that we haven't really seen in these places before. Warm air holds more water vapor than cold. Just one of the basic physical facts of this century. And that means that the dice are loaded for deluge, and downpour, and flood. And a bunch of places last year threw snake eyes. And the most remarkable example, well, there have been a bunch where you saw the pictures from Queensland and Australia. They were pretty remarkable. Same kind of thing's been happening in parts of Brazil and Sri Lanka, in places in the Philippines. Big, big floods killing lots and lots of people. The most remarkable example was what happened in Pakistan. Up in that region around the Khyber Pass, which normally gets about 3 foot of rain in a year, they got 12 feet of rain in a week at the end of July when the monsoon kind of stalled up there. And of course, that's just too much water. The Kabul River up in those highlands, the British, who were, you know, fanatic for measuring things, put in a stream gauge 100 years ago when they were in the middle of sort of great game politics up in that part of the world. And the highest that had ever been measured, the highest stream flow ever measured on the Kabul was 250,000 cubic feet a second. Well, last summer it got to 400,000 cubic feet a second, and then the rain gauges washed away. A quarter of Pakistan was underwater by the time that flood was over. The Indus had swelled so far out of its banks. The Red Cross said about a month ago that there were still 4 million people homeless in Pakistan as a result. That's pretty staggering to think about. And of course, it's worth bearing in mind, the way that it's always worth bearing in mind, that there's an almost inverse linear relationship between how much of this problem you cause and how quickly you get wrecked by it. It's a pretty good bet that your average peasant farmer along the Indus has done next to nothing to cause climate change. It's almost not worth just kind of, this is the biggest thing that human beings have ever done, and by a large margin. And we're only at the beginning of doing it. That's the scary part. We've raised the temperature of the planet so far 1 degree, a little less than 1 degree centigrade. We've added about 3/4 of a watt per square meter of the Earth's surface of extra sun's energy. And that's been enough to trigger all the kind of changes that I've been describing. The climatologists are robust in their consensus that unless we get quickly off fossil fuel, way, way more quickly than any government or economic actor is planning to get off fossil fuel at the moment, unless we do that, we're looking at 4 or 5 degrees before the century is out. And there is no reason on Earth to think that we can survive that. You know, the planet will still be here and there'll probably be people on it, but the threat to civilization that that entails is on a scale that we can barely even begin to comprehend. Among other things, teams at Stanford and the University of Washington said last year that just from those increases in temperature, forget changes in hydrological cycles and things that accompany, just those changes in temperature, that increase, is enough, they think, to reduce yields of our major grain crops 30 or 40%. Because wheat and corn and rice are just as adapted to the Holocene as we are, you know, maybe more so. They have roots. And there's no way to imagine a world that works if you're talking, no way to imagine development or anything like it if you're talking about a world that's running on a treadmill that's ever steepening and ever speeding up. All right, no more, I'll stop dropping heavy statistics on you. That's not even any use whining about it. That's just where we are, okay? That's the physics and chemistry of the situation that we find ourselves in. And so, the good part is we know that, Okay? This isn't coming on us blind the way it would have if it had happened 50 or 100 years ago when we lacked the scientific tools to predict, assess, understand what was going on. The scientific method has done its job and done it with great speed and power. The dialectic of science went to work, crunched this biggest problem in physics and chemistry, and produced a consensus more than strong enough for us to work from. That's pretty impressive in 20 years. Engineering method has been working pretty well too. 20 years ago, when people like me got up and talked about solar panels and wind power and stuff, we were basically doing it with our fingers crossed, because it wasn't really ready yet, you know? Solar power was still something that, you know, ex-hippies down in the basement with the, you know, wrench in the back pocket looking at the bank of lead-acid batteries and things were going on about. Clearly, that's not the case anymore. Clearly, solar power works just fine. Clearly, you know, wind energy is the fastest growing form of electric generation around the world, though it starts from such a small base that we have to speed it up immeasurably to make a dent. But the engineers have done their job too. The people who haven't done the job are the rest of us who are responsible for the operation of the kind of political method, you know, for making sure that those things that we know about the world are translated into action on a scale and at a pace that will actually make some difference. And that political method has failed completely. It's clear what its job needs to be, which is to move us very quickly off fossil fuel. It's clear that that's a very hard job, probably the biggest, most difficult and wrenching transition humans will ever have to undertake, at least on this short a scale, because fossil fuel is so deeply embedded at the center of our economies. And as a result, I'm afraid, of the difficulty of that task, so far, our political systems have just basically completely punted, not even made an effort to find out what we can do. 2 weeks ago, the US House of Representatives voted by a 60-vote majority to say that global warming didn't exist, wasn't true, wasn't real. That's one of those kind of votes that historians look back on 100 years later when they're trying to, you know, understand why Rome fell, or, you know, whatever. I mean, it's just like, it's not a good sign when your legislative body decides that it's going to substitute its own chemistry and physics for the one that everybody else is operating with, you know? And so that's a dark and tough moment. And so that's where I really want to start this talk, in a sense. I want to talk about what we're going to do and how we're going to do it, if we're going to do it, to get any of the places we need to go.